Hello, we will start again with the heart. Now before the heart can begin, the embryo must undergo 3 important steps within its first and second week of development. The first week of development is the implantation stage, in which the fertilized egg must implant into the mommy's uterus. The second is a bilaminar embryo, in which it divides into important bilaminar embryos. Yes. The third is a trilaminar embryo, in which it is divided into the endoderm, ectoderm, and the mesoderm. The mesoderm is then further split into the paraxial mesoderm and some others, but we care about the lateral mesoderm, specifically the splanchnic lateral mesoderm, which becomes the cardiac primary cardiogenic center. Initially, it is in front of the mouth, but then with lateral folding, with longitudinal or cephalic caudal folding, at day 21, the heart is able to go under so that the mouth is now in front. There's also lateral folding at the 3rd week, which gives rise to the gut and the endocardial tubes as they approach each other. Here is a beautiful picture of what we are talking about. Notice the notochord here and the folding of the myocardial tube and the endocardial tube with the endoderm. Here you see the folding, the cephalic caudal folding at day 21, where at first it's in front and then it folds here. And this is a future proencephalon. Beautiful, beautiful picture. It should also be noted that blood starts to form at day 17, which is important to know, and it forms in the yolk sac. During lateral folding of the 3rd week, the endocardial tubes fold towards each other to become the primary cardiac tube, which finishes between day 18 and day 22. They form together and merge through apoptosis. The primary cardiac tube has 3 important veins. The cardinal vein on the farthest right, ignore this part right now, the cardinal vein on the farthest right, the umbilical vein, and the vitelline vein. The vitelline comes from the yolk sac. The umbilical vein is important because it carries oxygen from the placenta, and the cardinal vein is from the body. We will learn more about these in important detail later. After the primary cardiac tube forms at the 3rd week, at the end of lateral folding with apoptosis between the 2 endocardial tubes. Yes. And it should also be noted that the ectoderm induces the cardiac primordial cardiogenic area to form the endocardial tubes. So the endoderm initiates the forming of the ectocardial tubes. Anyways, then you get sacculation, in which the primary cardiac tube forms these 5 important bubbles. So blood comes in this way through the veins and arteries that we talked about, through the horns, through the sinus venosum, through the premium atrium, premium ventricle, bulbus cortis, truncus arteriosus, and then exits through the first aortic arch, which is the efferent vessels. Each of these are important as they form something special. We will start at the horns. The left horn forms the coronary sinus and the oblique vein of the left atrium. The right horn forms part of the right atrium, which is important, as well as the sinus venereum, in which the superior vena cava and the inferior vena cava, as well as the coronary sinus, drain into the right atrium. So thus you can see how the right atrium can be involved in the formation here. Then you form, the sinus venosum, which, as we can see on this beautiful chart someone made, Oh, yes, this stuff here. Then we get the primary atrium, which form the right and left atrium, the primitive ventricle, which form the right and left ventricle, and then you get the bulbous cortex, which it also adds to the right ventricle. Something else also adds to the right atrium. Oh yes, okay. So it should be noted that though the primitive ventricle and primitive atrium both contribute to forming the atrium and ventricle respectively, the right atrium is also formed in addition to the right sinus venosus, and the right ventricle is also formed by the bulbous cortex. Okay, the left ventricle is all by itself right now. Then you have the truncus arteriosus, which forms the ascending aorta in the pulmonary trunk. Yes. The truncus arteriosus also elongates to form the truncus arteriosus proper and the conus corti, which we will learn about later. But right now we'll just focus on the basics. The umbilical vein, which we talked about here, the right disappears, so it's like no longer, right? Umbilical vein, bye-bye. And the left umbilical vein is oxygen-rich, as we talked about before, and forms the ligamentum teres hepatis. The vitelline vein, the left disappears, so goodbye. And the right forms the inferior vena cava and the portal system and the ductus venosum, which forms the ligamentum venosum, ductus venous, ligamentum venous, which involves shunting in the embryo. Then you have your posterior cardinal. So there's several cardinal. There's like posterior cardinal, anterior cardinal is like way up here, and middle cardinal, I don't really know. I have to turn the page for that. We won't worry about it right now. But the posterior cardinal, which is the one down here, that turns into that divides furthermore into the subcardinal and the supracardinal. The subcardinal helps to form the right inferior vena cava, and the left disappears. But somehow along the way, renal and gonadal are associated with them. I'm not really sure how. The supracardinal, the right furthermore forms the inferior vena cava as well as the zygos veins, and the left forms the hemozygous veins. We don't know where the accessory hemozygous veins are. Oh well. The anterior cardinal vein, the left forms the jugular and the subclavian, whereas the right forms the superior vena cava, the jugular vein, the subclavian vein, and the right brachiocephalic vein. If we go on to arteries, the umbilical artery forms the common iliac artery, iliac artery in the right and left medial umbilical ligament. The vitelline artery forms three things related to the celiac trunk, which is the foregut, the superior mesenteric, which is the midgut, and the inferior mesenteric, which is the hindgut. The right and left dorsal arches fuse to form the one dorsal arch, which then later on becomes a descending aorta. Then we move on to the aortic arches, where the first one is formed by part of the right and left maxillary artery, the second is formed by the stapedial artery, the third is formed by the right and left common carotid and internal carotid. The fourth arch, the left, is formed by the aortic arch, whereas the right side is formed by the brachiocephalic trunk and the subclavian. And the sixth arch, the left side forms the ductus arteriosus, and the left forms the right and left. And then also together, they form the right and left pulmonary arteries. So it should be noted some things that are distinctions that you might not always know. As we talked about before, the bulbous cortex adds to the right ventricle formation. The right sinus venosum adds to the right atrium formation. The aortic arch is formed by the fourth aortic arch. Let's go in order here, I'm sorry. The truncus arteriosus forms the ascending aorta. The aortic arch is formed by the fourth aortic arch. and the descending aorta is formed by the right and left dorsal aortae, which fuse together to form one dorsal arch. Thus, it's important when you make the distinction of the aorta to note if it's ascending arch or descending, as it has different embryological origins. Furthermore, it should be noted that the umbilical right side of the vein disappears versus the vitelline left disappears, and the cardinal vein, specifically the left subcardinal vein, also disappears. I hope this was helpful in your study of the embryology.